makes you feel better, I feel the same way. Recording. Okay, good. So, last time, lists. I introduced lists for the first time last time, but of course you already saw lists, right? We've been using them already a whole bunch of times. And we also saw how strings are basically kind of like lists. Although we did see some funny things about strings. But let's start with a little activity. See if we remember what we figured out. And you'll notice some of these things that we're going to do are going to be very similar to what we were doing remember it was yesterday or the day before, with, I guess it would have been Friday, with the strings. So here's what I want you to do. So figure out how to find the number of elements in a list. I kind of already did that one for you. Write a function, print list, that takes the list, L, you can call it whatever you want, as an argument and prints out the elements of the list. And I don't want you to just say print L. I want you to kind of like iterate through all the elements in the list and print them out. And then try if you can get only the even numbers. That'd be interesting. Just have a go at it. I'll give you a couple minutes for this one because I want to make sure you get a chance to play with lists a little bit more in an environment where we're actually learning lists and I just haven't thrown you into the deep end yet. Also, one little tip I'll give you is, especially when we're just starting to learn lists, I highly recommend making a list of like letters and not numbers, because otherwise you can get confused what's in the list versus the indices of the list. So I recommend doing that for this stage. Who here had something like this for that one question about printing the contents of the list? Yeah? Was it because I didn't give you enough time? Or did you have something completely different? You don't know? So all this is, I mean, if we go back and look at the code we did from yesterday, or no, I think it was last Friday with the strings, is we did this. But remember, with the for loop, it's like for each thing in the collection of things. But when it was strings, it was a collection of like individual letters, right? But now we have a list, and a list is a little bit more general. It can be a series of whatever. So here, it's for each thing in the list. And what do we have in the list? Well, we saw up here, I did like A, B, C, D, E, F, G. So the first time through the loop, we see A, because that's the first one. Then the next time through the loop, B, C. And the loop will keep running until it runs out of things. So the last thing to be run, the last thing to be printed will be G, and it just stops for us. Did someone do it with a while loop? No? How about, did someone do it where they were using indices to get the elements from the list? No? Maybe I went too fast and I spoiled the fun for you. Didn't give you enough time to finish it. Printing out only the even numbers, that's a little tricky. Technically, you have all the tools in your tool belt to do this one, but it might be a little easier after we revisit this topic. So maybe we'll skip that one for now. How about this one? Did anyone get this? Check if an element is in the list. No? One person, I remember from previous class, asked me why I wasn't just doing like in when doing a linear search, right? Because if we're looking for something, if something's in that list, we know we have to do that linear search. Where before we were looking for a letter and a string, well now we've got a list, so we're looking for something, we want to know if that thing is in the list. And we saw that linear search. We had to do like a loop that then compared each element to the thing we were looking for. And who remembers when we know if something is not in the list? Can anyone yell it out? False isn't the answer. That would mean that it's not in the list, that like maybe the function returns false. If we get to the end and we still haven't found it, then we know it's not in there. Not once before. And this is important to remember because a lot of times, especially at this stage when we're learning, we might say, okay, here's the loop and go through each element in this collection of things. And we ask the question, if the current element is equal to the thing I found, is equal to the thing I'm looking for, we found it, right? And as soon as we find it, we know if that thing's in the list. So we can immediately return true and stop the search. So if we have a list of size 1 billion, and the thing we're looking for is at the very beginning, in index 0, how many times is that loop going to run if we're looking for the thing at location 0? Somebody yell it. Huh? Particularly sleepy day? How many times will that loop have to run? It's not a trick question. Someone's got to know. Let me restate the question in case you weren't listening. I've got a list of 1 billion things. And I'm doing a linear search to see if a given thing is in that collection of things. There's 1 billion of them. And it just so happens that the thing I'm looking for is at index 0. So how many times will that loop have to run before it knows it found the thing? 1, of course. It only needs to run once. But a lot of times we might be tempted to say, so if we find it, return true, else return false. But of course that's no good, because that'll only ever check the first element. It'll say, is the very first thing the thing I'm looking for? If it is, great. If not, return false? No, because we don't know that it's not in there until we get to the very end. Anyways, so if there's 1 billion things and the thing I'm looking for is not in the list, but there's 1 billion things in that list. How many times will that loop have to run in order to know that the thing is definitely not in that list? Huh? A billion, of course, a billion. What if it's 2 billion? How many times? What if it's n? How many times? N, exactly. So remember, the amount of work we're doing for this linear search grows proportionally, linearly proportionally. That's just a fancy way of saying, like if we double the size of the list, we have to do twice as much work. And this is a very important concept in computer science. And I think it was Friday we were doing the linear search. This was the first time we were introduced to the idea of how much work an algorithm is doing, dependent on how big that list is, which is interesting. And computer scientists really like to geek out about that type of stuff. But anyways, who remembers the shorthand in Python to do a linear search? Well, Python's really great. It'll tell you if like 5 in 5, 4, 3, 2, 1. What? Oh, it's because it's a list of lists. There we go. Python's great. You can do a linear search in one line of code. But of course, that little nice one line of code, in the end, it's still got to do that linear search. Whether we wrote the code to do the loop or Python's just doing it for us, it's still getting run that way. So some operations we can do with, oh yeah.
Sorry, I don't know if you said this yesterday or maybe I missed it, but could you do that same thing with like 5 in, like with a list, but use like the list name instead?
Oh, yeah, for sure.
Yeah, okay.
Yeah. So what he was asking is this. So I said this, right? But what if I've got a list and its characters? Well, I can do like, is 5 in a list? Well, that'll be false because I'm looking for 5 and there's no 5 in it. But if I'm looking for E, well, there is an E. So yeah, we could use the variable name. Because remember, the variable has the value. And, in just is looking for some value. Whether it's a literal or a variable, it doesn't care. Anyways, so some operations we can do with lists. Remember how with strings we can concatenate them together? How weirdly, although addition is an operator we use on numbers, we can use it on strings in Python, and that just simply concatenates the strings together. Puts them one after the other. Same idea with lists. For example, there. I've got, 2 lists there. If I add them together, I get just the bigger list of them stuck together. And similarly with strings, how we can multiply them by some number, we can make the list repeat however many times. So A from above is 5, 7, 9, 10. Well, 5, 7, 9, 10, 5, 7, 9, 10, 5, 7, 9, 10. Cool. It's pretty handy if you want, you might think, well, why on earth would I care about doing that? Sometimes it comes up. Maybe you want to create a list of size 100, and all the values are supposed to start at 0. Who wants to write this? 0, 0, 0, 0, 0, 0, 0. I don't want to write 100 zeros, right? So we could very easily just do this. And then I guess just print A. Ah, fantastic. Look, I didn't need to write them all out. Saved myself a lot of pain and suffering. Range. So we've been using range a little bit, but now let's actually talk about it. And I will warn you that, annoyingly, for better or worse, there was a bit of a switch with how range works in Python 3 versus Python 2. So if you watch the video down, one of those videos, the difference is minor, but just be aware that there's a slight difference. When you use range, it gives you back, asterisk, a list of whatever the range is. So we'll see in this example, range 1, 5. It gives me a list of the numbers starting at 1 all the way up to 5, but we don't include 5. Remember that. It's weird. We always exclude that last one. But we saw that there was good reason for that because we always start counting at 0. It's a whole thing. So range 1, 5 gives me that list. But you'll see that I had to write range 1, 5 and then wrap it in list. You see that? That's like a Python 3 thing. It's because in Python 3 it creates something called like a generator, which just is, from an engineering perspective, is better. But the point is that that's actually a list. So we can create lists this way really easy. So what if I want a list of, let's say A equals, what do I want here? Actually, let me show you what I mean. Range of, if I just put one number in, it'll assume you want to start at 0 and go all the way up to, but exclude 500. This and this are the exact same thing. So I hit run. If I print, hey, what do I see? It tells me that it's like this range thing. In fact, what's the type? It's a range? Well, that's because it's like a special object that is like that list, but it has some interesting properties. If this was Python 2, and I said, what's the type of A, it would say list. It would actually just be the list. So do note that that difference might pop up if you're watching the videos that were based on Python 2. If you really want it as a list, we say list. Just be like, look, I know you're a range object, but just be a list. And then we run this. Sure enough, it's a list. Great. So this is really handy. And you might think, this can be super handy because we saw for loops. And remember how for loops, if we're iterating over something, for loops were kind of a pain, right? For loops are great because, I said that wrong. For loops are great if you're iterating over a thing, but while loops were kind of annoying in that sense. We had to make a counter and then increment the counter every time, check if that condition is true. Remember? There was a lot of extra boilerplate code you had to write to get the while loops to do the trick. While loops are fantastic to just check if you want to do the work over and over and over again. If you want to rerun that code based on some Boolean question. The Boolean question might be, is some counter less than some value? I get that. But for loops are great when you want to iterate over a collection of things. And for loops, we can hijack this functionality with range to have a for loop iterate over all the indices that are available in a list. Let me show you what I mean. If range is giving me a list, I'll delete this. Let's say for I in range 100. Let's make it 10 for easier to read. Okay, I'm not going to hit run yet. You probably haven't seen this code yet. You haven't seen someone write something like that. But I want you to take a second and think. You have all the tools in your tool belt to know what this will do. Don't look for any shortcuts. Don't look for any tricks. What does the code say? And remember that range is giving us back a list of the numbers 0 through 9. So what will this do? Oh, let's give everyone a chance to think. So now I'm not asking you to answer, but I just want to do a poll. Raise your hand if you're like, yeah, I think I know. Really high, I want to see. A couple people. So let's see if you're right. Look at that, 0 through 9. So we hijacked kind of the functionality of this for loop with this range object thing, where I can say, if I put 10 in there, I know that that loop's going to run 10 times. If I put 100 in there, how many times is that loop going to run? Yell it. 99. Nope. 100, because it starts at 0. It'll go up to 99. Ah, I gotcha. So it'll run 100 times. If I put 1,000 in there, how many times will that for loop run? 1,000. If I put n, how many times? N. One person said it, but come on, wake up. So this for loop is a great and handy way. We can hijack the for loop, which iterates over each thing in the collection of things. It's a handy way if we need a quick and dirty loop to run some number of times. It's fantastic. So now we don't need to say counter equals 0. Well, counter is less than the value, whatever, counter equals counter plus 1. And I know you're saying like, well, what's the difference? But remember, computer scientists are exceptionally lazy. We want to write very few lines of code. That while loop is just too much for me. So I like this for loop. And for those of you who have, raise again, I know I asked this the other day, but raise your hand if you have experience in like Java, C, C++, or something really high I want to see. So for those of you that have used those languages, this will probably look similar to what the for loops you're used to are. But technically, it's not. It's actually the for each loop, but we kind of trick Python into thinking that it's those types of for loops. Anyways. Oh, I kind of ruined this activity a bit, but yeah, let's do this one together real quick. I want to print out all the integers from 0 to 17. Okay, great. So I can say, wait, do I want to print them out or just get the lists with that? All right, fine. A equals list of range. If I want the numbers from 0 to 17, what number do I put in there? 0 and 18. Why 18?
Because you count at 0.
Right, and it won't go up to that 18. It's always up to, but excluding that number. So 0, 18. And then here, let's print A. Look at that, great. But of course, like I just said, I actually technically don't need to put the 0 there, because if I give it one parameter, it assumes we're starting at 0. Cool, great. What's the next one? Negative 10 to 0. Huh. Well, that's weird, but let's just follow the rules. What should I put in here if I wanted to do negative 10 to 0? I'll give you a second to think, but if you know, yell it out.
Negative 10 to 1.
Okay, negative 10 to 1 makes sense. Where are we starting? Where are we ending? But excluding the ending one. So let's see, negative 10 to 1. Yeah, there we go. That's not too bad. Range looks pretty handy, eh? What's the next one? All integers from 10 to 0. So counting down. Huh. This one's tricky. So 10 to 0. Well, what if, okay, actually, maybe this isn't too bad. Like 10, 0. Start at 10, go to 0. That's no good. And I mean, I suppose I should do negative 1, right, too, if anything. 10 to 0. Does anyone have any idea what's up? Yeah.
The absolute value of the one you did before with the negative 10 to 1.
So what do you, what do you want me to write?
I don't know how you do it, but isn't there a function in Python where you can take the absolute value of the number?
Yeah, so what number do you want me to put abs around?
Like, in the print.
Like this?
I think so.
Let's give it a go. I guess not. I like the way you're thinking, though. Like, I know where you're going. You're like, well, the negative, it's throwing it off.
What if you leave it as the absolute value and then you put the negative 10 to 1 back in?
Wait, so tell me what to write.
In the list range, do the negative 10 to 1, and then you put the print absolute value of A.
Print the absolute value of A. Well, that's what we just had.
No, but then within the range function, go back to the negative 10 and the positive 1.
Oh, okay, negative 10, positive 1.
Yeah, and then take the absolute value of there.
Like this?
I think so. No, okay.
Same problem. I like the way you're thinking, though. It's, you were answering the whole time. Let's see if anyone else has an idea of what's wrong here. See, the problem is This says, range works like this. It says start at this number and count up towards that number. So this is asking, like before when we put -10 and 1, that says start at -10 and count up towards the number until you run out of numbers, until you hit what you're looking for. Right? That's what it does. So now I say, start at 10 and start moving towards -1 by counting up. Is that possible? How do I go from 10 by adding 1 to get to -1? What were we going to say?
I reversed it.
You reversed it. How'd you reverse it?
List, and then reverse, and then range 0 to 11.
So you did like, so you did this, 0.
No, I did list, bracket, reverse, bracket, range, bracket, 0 to 11. Reversed the D.
Like that?
0 to 11.
Do I not have enough brackets? Well, there you go. That'll work. There. What a great solution. But there's a cooler solution, actually. Actually, I shouldn't say cooler. This is actually pretty great. Good find. Did you know about reverse, or you're like, what happens if I type this?
Googled it.
You Googled it. Even better. Remember, that's the #1 skill I want you to learn in this class. So here's the problem. It counts by +1 by default. We can actually tell Python, we can tell this range function what we want to count by. There's a secret third parameter that we can add. By default, it's this. You have this secret third parameter that says count by ones. Count by +1s. But what do we want to count by? -1. Oh, print it. There we go, cool. And if we learn about this count by, I guess, if I do like 0, 10, count by 2s. Well, that's neat. So range is actually a really powerful function that people I guess it's like an object, that people kind of forget about sometimes. They get used to using them only in for loops, but they actually come up in a lot of great places. Anyways, any questions about range? There is one important note though. If you ever want to do count by, you have to include, like if you ever want to use that secret third value, that secret third parameter, you have to include 0 or whatever number you're starting at in there. Because it's positional. So you might say, well, that means start at 0, go to 10, count by 2s. But how would Python know that? Right now it's assuming that you're actually saying start at 10, go to 2, count by 1s, because that's default. So you just got to be careful. If you're ever using the count by, you got to have those 3 values in there. Unless you know the values of the parameter names and do the equals, but don't worry about that. Okay, so remember, at this stage you're thinking, yeah, strings and lists are pretty damn similar, right? They do, they kind of do the same thing. Strings are limited to only having like letters in it, but we can access those values. But there was one issue with strings. They're not mutable, they're immutable. Here's what I mean. A. I can print A at location 1 and get E, great. But I can't do A at location 1 now equals O. It won't let me do that. I cannot go into that string and change that string. Now, I kind of showed you a workaround before where, well, you can make like a copy, like you can build a new string based on the old string, but you're not actually allowed to change what's in that string, the actual string. I wonder if this is true. So I have a list. Let's print a list. And let's do like A list at location 1. Let's get rid of this just to make sure everything's running just good. Okay, great. So here's our list, A, B, C, D, E, F, G, and I said, give me A list at 1. Great. We see it. B. Why B? Well, we start counting at 0, don't forget. But with the strings, I tried to assign something. Let's see what happens with the list. Oops. Look at that. So not only can lists, not only are lists more general, we can put whatever value we want in there, but they're mutable. We can change them. We can change the contents inside that list. So this is pretty handy. So here, yeah, let's do this activity too. I've been talking for a while. Let's give you a second. Do this. Consider this list, L equals list, range 0 to 10. See if you can change the fifth element of the list to an X or something. And then replace the first two elements. Just, there you go. Try this. I'll give you a couple minutes. See if you can do it. I will admit that number 2 and 3 are kind of tricky. And I suppose for one, it's kind of ambiguous. When I said fifth, did I mean index 5 or the thing that's like the fifth that we start counting like 0, well that's the first, or is that the 0th? If you were scratching your head on that, you're right, you're normal. It was ambiguous. If this was an assignment, I'd have to be more precise, I suppose. Raise your hand if you got the first one done. Yeah, okay, that was kind of the easy one. Did anyone actually get the second one done? Oh, a couple people, there you go. So presumably you remembered slicing. How about the third one? Okay, good. But let's do those together because they were a little tricky, especially if you don't, we talked about slicing very briefly. So there's the first one, great. And then it said what? Replace the first two elements. Okay, great. So you might remember that L at 0 to 2 Well, let's just print this out just to make sure we know what's going on. So that's 0, 1. Those are the first two elements. So I wonder if I can like assign, what am I supposed to change it to? To 10 and 11. Okay, so 10, 11. Let's see what happens. Oops, I guess I got to print it out. Okay, it worked. Great. Is this what you did? For those that got it, yeah? Good, cool. And then I can kind of do the same idea, but what happens if I replace it with an empty list? Well, replace these two things with nothing. Okay, cool. Cool. You could also delete things in Python with this del keyword. You might find that handy. Admittedly, I've used this like, I think my Google just talked to me. I think I've used del like 4 times in my life, but it's a thing. Okay. So remember last time, yesterday, I left you hanging with this, right? Let me go here. Remember how I did this yesterday? And I was talking about like, whoa, mind bending. What's going on here? You're appending the list to itself. What the heck does that mean? Well, now we could start talking about what the heck just happened and why this actually makes perfect sense. I will warn you that if there is a topic in first year, first semester, computer science that confuses students the most, it's this. I'm warning you that this will leave you scratching your head. In assignment 3, if you don't understand this, assignment 3 will be very painful. But listen to me when I say it's the same story. There's no tricks. There's no magic formula you need to follow. There's no secret. The only secret is, what does the code say? Follow the rules. So here's the problem. If I show you this code, and this block too, does anything in that look weird to you? Because it really shouldn't, right? I'm going to put it into Colab. A equals 5, B equals, okay, blah, blah, blah. Let's go down here. A equals 5, B equals A. Print A, B. And then what did I say? B equals 7. Take a second, make sure this makes sense. There's no tricks here. When I was saying hand wavy, ooh, complicated stuff, this isn't it. This is the precursor to the complicated stuff. Anyone have a problem with that code? It's not special, right? All it means is, okay, a variable A now has the value 5, so A is 5. B, oh, well, that's going to have the value A has, right? So A and B are both 5. Print them out. Yeah, sure enough. And then I say, oh, no, B, you have the value 7. Put the value 7 in B. Print it out, 5, 7. Great. Nothing weird here, right? Now here's a bit of a problem. And you might remember when I'm talking about strings how we had a bit of an issue, and this is really very much tied to the issue of like I can only put a letter in like a certain block, right? Like I was saying, pretend you guys are letters. Like you can only fit in like one seat, right? If I have a whole bunch of letters, I can't shove all those letters in one seat. I got to have a seat per letter. So if I have a regular old number like 5 or 7, it's great. Like, you know, it's a box that I can fit an integer in. It's happy. The computer's very happy. So now let's consider the case where I have a list called big list. That's the variable. And it's a list with 500 billion entries in it. That's a big list, okay? Even for how big and fast computers are now, that's a big list. And I come along and write something very similar. New list equals big list. Very similar to B equals A, right? It looks like effectively the same idea, right? Let's think for a second. When I said B equals A, I copied over the contents of A and put it into B, right? Nothing, yeah, that's what happened. Now, we've got that problem of like, well, where are the contents? I've got 500 billion of them. What are we going to do here? If I say something like, new list equals big list, do you really think it's a good idea to make a copy of those 500 billion things? I don't care how fast your computer is, that's going to be painful. Computer is not going to be happy about that. So instead, here's what the computer does with lists. It creates an alias. An alias is a little bit different than like, oh, both A and B are 5. Well, in our example, new list and big list both mean that list of 500 billion things. Both of those variable names mean the exact same list. Where when they were simple things like those integers, the 5 and the 7, they weren't the same 5 stored in the computer. There were 2 copies of the 5. So, here. What do we say here? Just for simplicity, B equals A, print A and B. I'm going to get rid of this bit for now. There. Oh, ooh, you know what? Let's get rid of this bit. We don't want that weirdness. There. So I said A is A list. That's because I was too lazy to write out A, B, C, D, E, F, G. Okay, great. We've got the list A, B, C, D, E, F, G. And then I said B equals A. So, you know, A, B, C, D, E, F, G. Makes sense, right? This seems very similar to what I did with the integers, the 5 and the 7. But remember how I can change 5. I can change B. Let's see what happens if I change. I'm going to change B. So B at location 0 equals X. Let's make it a capital X so it's really obvious. Okay, let's see what the code's saying right now. Okay, A and B, okay, print out A, B, C, D, E, F, G. Print out B, A, B, C, D, E, F, G. And then I go in and say B at index 0 become X. And then I print out B, X, B, C, D, E, F, G. So far so good, right? Nothing weird. What's James talking about? This weirdness that's confusing and scary. Well, hold on to your hats. I'm going to print A as well. Oops, I guess I modeled. Let me restart. There. I didn't want to change A. Did I ever write A at 0 equals X? Did I ever write that? No, of course I didn't. Yet, somehow A at 0 became X. What's going on? That's because, and let me grab a marker. What I've done is, I've got one list. And I've got A, B, C, D, E, F, whatever, G. We lost it. And I have big list, B, L, or in this case I've got A, I guess. Where's the eraser? draw it a little nicer there. So I have the variable a. That gets me that list. If we go back to the world of the integers, we had a equals 5, b equals 5. So we have like a gets us to the 5 and b gets us to the 5. It's fine. But remember, we didn't make like the copy of the contents of the list. We created an alias. So what this ended up doing when I said b equals a, this is what I got. Even if I modify a at 0, or perhaps I modify b at 0, I'm changing the same single list. There's only one list here. And that's why that happens. This right here. That's why what happens. That's why that happens. If you're expecting b equals a to make an entire copy, you're going to be very unhappy. Because it seemed to do the exact, like, that's what seems to be happening here, right, with these integers. It made a copy of the 5. Oops, actually, I meant to say, I wrote this wrong. How come no one stopped me? B equals a. Like, it's like, oh, okay, it's got the value 5, great. And then when I changed it, it changed it. It didn't matter. But it's because there were 2 5s. Where over here, there's only one. So if you expected it to make a copy like this seemingly does, you're probably really unhappy right now. Raise your hand if you're like, I don't like this. I got bad news for you. Deal with it. If you're like, no, why would I make a copy? It's great. It's just another name for the same one thing. Then you're probably happy. Fine. But this is where things get weird. And this right here, this whole issue of aliasing, is where people start to get confused and frustrated. But, and we won't have time for it today, I am going to give you blah, 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 blah. See, the cat's sad. On Friday, I guess we gotta wait till Friday, I'm going to explain to you how actually what's really happening inside the computer between that and that, how, oh, that's not making a copy, it's just an alias. Actually, technically, how these computers work, how these computational systems work, and how Python works, technically, it's doing the exact same thing. But you just have to know about some critical, super important idea. And that critical, super important idea is something called pointers. I'll give you a very, 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 very quick explanation of that. Technically, when I say, oh, A is this, it's not actually that. A is not this list. A and B is not that list. A and B, these are boxes, right, that have labels. And if they're integers, I can put like 5 in there, or 6, whatever, it's happy. But when I have something like a list, remember, I don't have, like, everyone's being good in social distancing, so I don't have a good example. But if I had a list of 1, 2, 3, 4, 5, 6, 7, 8, 9 things, I can't shove those 9 things in this box, right? So I don't have that available to me. But I do have RAM all throughout my computer. So I can go find a chunk of RAM that's, 1, 2, 3, 4, 5, 6, 7, 8, 9, big, and say that's where my list is. I'm saving it over there. It's somewhere else in RAM. Pretend this is it. This is like RAM. And it has the information. Great. So what's in this box really is, hey, here's where to find the beginning of that. It's what we call a pointer. It's the memory address of where this starts. Right now, I'm saying a lot of words, that's a lot of jargon that you don't really know yet. We've talked about it lightly. It'll make sense on Friday. But what's really inside here, effectively, is pointers. And when I said b equals a, I copied over what was in there. It's just the memory address of where that starts. So it actually does the same thing. So do note that a, it's a list. Actually, that's not true. A is never a list. B is never a list. You can never have a variable that's a list. You can have variables that are pointers to lists. All right, we'll stop there. See you tomorrow or Thursday, depending on which lab you're in.